Okay, well, new chapter here, and we are going to start off with what might seem like some pretty mundane stuff, but it's going to, the sections are going to build on each other, and with this, even though we're starting off with composition of functions, that's going to lead us to exponential functions and logarithms, which is going to lead to exponential growth and a lot of the modeling that's associated with compound interest and financial modeling. So we're approaching we're going to start mundane, but we're going to hopefully build on things that will get us something very useful. So composition of functions, this is basically, we've done a little bit of this before. Basically, we're substituting one function in for another and getting another function. Okay, so this is yet another operation on functions. So if f and g are functions in which the domain and range are subsets of real numbers, that means the inputs and the outputs are real numbers. We define two functions associated with this: f circle g, which we we can call it f circle g or f composed g, and g composed f, by the following. We say f circle g is a function that sends x to f of g of x, and g circle f is a function that sends x to g of f of x. These are going to be two different functions almost all the time. And I say where this makes sense, because the domain of a composition depends on a lot of stuff. In this case, obviously x has to be in the domain of g, and g of x, whatever that is, has to be in the domain of f. Here, x has to be in the domain of f, and f of x has to be in the domain of g. Okay, so rather than write all this stuff out, I just say where this makes sense. Okay, I want to emphasize, obviously, you can't plug something that's undefined into a function, right? So, in particular, f of x and g of x have to be defined. So these are called composite functions, or the compositions of f and g, and almost always f circle g is not equal to g circle f. We're composing functions, we are not multiplying them. So just doing a few examples here. And the best way to do this is just to go back in here and copy one of these down and then proceed from there. So f circle g of x is f of g of x. And then work from the inside out. G of x we said is x squared. And f takes whatever it's given and adds 3 to it. Well, it's given x squared, so this is going to be x squared plus 3. And that's it. G circle f of x is g of f of x. F of x is x plus 3. And g takes whatever it's given and squares it. So it squares x plus 3. Okay, and that's the composition. We can also multiply this out, and this will be x squared plus 6x plus 9. Okay. We can compose a function with itself. This is just replace, so this is just going to be f of x. So you take f of x and plug it into itself. This is f of x plus 3. And once again, f takes whatever it's given and adds 3 to it. So this is x plus 6. Likewise, g circle g of x is g of x. And this is going to be g of x squared. So this is, of course, now g is squaring x squared. So it's x squared squared, and we know we can multiply these exponents, and we get x to the 4th. So it's just plugging stuff in and simplifying. We can also evaluate the compositions at special numbers as well. F circle f of 0, this is f of 0. And again, the best way to do this is just work your way, start from the inside out, and work your way out. So f of 0, we plug 0 into, well, this is f of negative 3 times 0 plus 4, which is f of 4. And then f of 4 is negative 3 times 4 plus 4. This is negative 12 plus 4, so that's negative 8. Okay. G of f of 2 is g of f of 2. F of 2, let's say, so this is g of, now with f of 2 is negative 3 times 2 plus 4. So this is negative 2. And now we plug negative 2 in here, so this will be negative 2 over negative 2 plus 5, which is negative 2 over 3. F circle g of negative 3, that would be f of g of negative 3. This is going to be f of, okay, what is g of negative 3? That's negative 3 over negative 3 plus 5, which is f of negative 3 halves. Negative 3 halves, so that now we plug negative 3 halves into here. This is negative 3 times negative 3 halves plus 4, which this will be 9 halves plus 4. That's 9 halves plus 8 halves. That's 17 halves. And then finally g of 1. G of 1 is 1 over 1 plus 5, or that's g of 1/6. Now we plug 1/6 into g, we get 1/6 over 1/6 plus 5. Okay, it's kind of an ugly number, but you can get common denominators, or you can just multiply both the top and bottom by 6, and what this becomes is 1 over 31. Okay, if you leave it like this, I'd probably accept it, but you should be able to simplify this to this number. Okay, and that's what so far this is. Now, finding the domains will be a little bit more interesting, and that's what we'll do in the next part of this video.